So I switched up some of the examples, and we're going to try and go through this just for more practice with Liate. The more you do it, the easier it gets. And by Liate, I actually mean integration by parts. That's my quick abbreviation for integration by parts. IBP, that is just the lazy man's way of writing it. In each of these examples, you need to figure out what's going to be U and what's going to be dV. If you can do that, you're in good shape. Using Liate, which comes first, the algebraic or the logarithm? Looks like logarithm comes first, so that's going to be U, and the rest of it is going to be dV. When we come to the next one, we have algebra and trig. To me, it looks like algebra comes before trig, so that's going to be U, and this is going to be dV. Now, it gets a little trickier when you have algebra and algebra. If you have two parts which are algebra, and this is in the notes also, here's a tip. Let the more complicated part be equal to dV. For example, I'm going to let the square root of all that equal dV, and then the simpler part be equal to U. That's only if you have two that are algebraic. And down in the bottom one is a special situation we'll get to in just a second. Let's take a look at these. Number 2. Looking at number 2, we split up the U and the dV. I rewrote it, I just switched it, so it'd be U, dV, whatever. And to find du and v itself, you need to integrate the green. Let me say that again. You need to differentiate the green and integrate the purple. Once again, don't worry about when you integrate getting a plus c. That's going to come. Now that we have u, dv, v, and du, just regurgitate, copy, imitate that exact same formula to get something like this. We've got u times v minus v du. And with a little simplifying now, that integral that's inside there is going to be easier to solve. Simplifying x squared over x, moving the 1/2 out front, we get a much simpler power rule with a solution of, ta-da! That's example 2. Now example 3. In example 3 up there, we already figured out u and dv. To find du and v, derive and integrate. Looking at the details here, notice du actually equals 2x times dx. The derivative itself is du over dx, but if we want du, the differential of u, you have to multiply both sides by dx. Likewise, over here, this should include sine x dx, and then when you integrate, it will just be negative cosine. Now we can plug in our formula. This will equal uv minus v du, which is easy enough to copy down. But now, unfortunately, if we look at what's there, we might need to do something about that integral. That second integral over there, we can't solve it. It still has an algebraic and a trigonometric. So we'll just do integration by parts. Part 2. That's right. If you cannot integrate that last part using integration by parts, just do it again. And we set it up with u and dv. Once again, algebraic comes before trig. And so we derive and integrate, bringing us to an equation which isn't too bad to do. Now, this part was already completed, but the integral over here will become uv minus v du. Just doing it a second time, the integral of sine is much easier now. The rest of it all comes together well. The final answer equals that. How many times can you do integration by parts? You could literally do it 3, 4, 5 times before you're done. Luckily, we have a shortcut for doing that. We'll learn that in another video coming soon. Finally, for example number 4, we've already found u and dv. We set it up. Remember our tip here, if there are two algebraic parts, let u be the simpler part, dv be the more complicated part. And we derived to get 1 times dx, and we integrated to get that new part. Once again, integration by parts lets us know this will be u times v minus v times du. That second integral, move those 2/3 out front, get them out of the way. We've got a straightforward integral there.